Hello, my name is Ryan, and I'm a rising senior studying industrial operations engineering at the University of Michigan. This video serves to go over the power management system we use for our boat C3PO, as well as some of the improvements we made over the course of the year in preparation for the RoboBoat competition. I'll now pass it over to one of our electrical leads, Arjun, to go over the electrical box in more detail.
Hi, my name is Arjun Anand. I am the current electrical lead for Autonomy. I'm a rising junior studying computer engineering. While you're looking at the box, I want to highlight a couple design methodologies that we implemented this last year. First, we wanted the box to be much simpler than last year because we had not enough time because of the pandemic, and that was a concern. We were able to accomplish this by careful planning through computer-aided design, custom circuitry, and choice of components. So with computer-aided design, we were able to lay out everything on SolidWorks before we started to even purchase the box, and as a result, we could minimize the wires that went between components to make sure everything was as neat and as organized as possible. We had to design custom circuitry in order to fulfill our needs, more as we need rather than what a manufacturer chooses to give us. So this took a lot of planning, either 3D printing or making PCBs. We had to do all of that work in order to make sure everything was organized. And lastly, we needed to choose some components that we didn't have last year in order to make sure that everything was simpler. Next, we wanted to be reliable. In previous box iterations, wire was thrown everywhere, and even light tugging on some wires made us a bit nervous that something could have been dislodged. As a result, we used Anderson connectors to speed up wiring process and also making it way more reliable. In previous years, we soldered everything, but even for a professional solderer, reliability can be a concern sometimes, and there's no doubt that it takes a lot of time. And as I mentioned, we were able to about half our time doing all the connections with these Anderson connectors, and it's a lot easier to pick up and do reliably. And for our lower voltage connections, we use Wago clips that we don't have on right now, since we're using them for prototyping, and we were able to quickly snap on wires to interconnect them rather than soldering them. Lastly, we wanted to be neat and organized. This was mainly done through this green circuit board you see right in the middle of the box. In the past, we used an 8-hex cable, and we cut it in half and soldered all of our outputs and other wires that are needed into that to supply power to them. But we were wasting this cable, and they're very hard to find online. So this year, we bought an ATX breakout board. So we plug this ATX cable into that board, and we just have all of our voltage. We have all of our voltage supplies coming out of that, so we can save the cable, and we're also making it a lot more neat and organized and easier to track if something goes wrong. One of the things that we are most proud of in the box is this rotary switch that we use for batteries. If you recall correctly, last year we had something similar, but this year we expanded upon that and have a better product. Last year we didn't have diodes, so there could have been an issue if two batteries were plugged in at the same time for a long amount of time, with the current flowing back into the battery, and this was a safety concern. And obviously, safety being very important on our team, we wanted to ensure that nothing could go wrong. So we implemented these diodes here so that current can only flow in one direction. So to recap its usage and importance to us as a team, let's say a programmer needs to read data from the box, and one of the batteries that we're using on the box is currently low. We don't want to unplug the battery because then the programmer would not be able to read anything from it and their work would be disrupted. And if we just use the regular switch example, there wouldn't be really any way to do this. However, with this rotary three-way switch, we can plug in another battery into the other slot, as you can see. We can make the switch draw from both batteries, then we can unplug the low battery. And then we can turn the switch to the new fresh battery. So this allows us to cleanly exchange power inputs to the box while not turning the box off completely. And this has been really important to us as we've been debugging a lot this year and making sure that the boat runs for a long time without disrupting the programmer's work. As you can probably imagine, the box, when it's all done and complete, would be a lot more full than it is currently. The reason it's not full right now currently is because we had boat testing the other day, and we wanted to make sure that the box was as light as possible and as tested as possible in order to make sure that we didn't have any malfunctions or things that could go wrong unexpectedly without thorough testing. So as a result, we removed some of the volatile components that haven't been tested yet. Um, because safety is very important to us, we wanted to make sure that everything that was in the box was something that we tested thoroughly, and we really cut it down to the bare bones components. Some of the wires going to outputs was also taken out. This is because it cluttered the box if something went wrong during the debugging session. As I mentioned before, putting these wires back in would be very, very simple due to the locking connections that we bought this year. In addition, we needed these wires for prototyping. Since they're very precisely sized wires, we needed them for prototyping our currently designed and made PCBs and future components that we plan to use on the box. Last thing I'd like to talk about is some of our computing elements and future improvements that we plan to include before next year. So we have a Titan RTX that we plan to put in this box in the motherboard in order to increase the amount of sensors we can have connected to the box, and to increase the total speed and performance of the box and all its peripherals. In addition, we have these buck converters that are they're very big, and they don't really provide a need per se. We have them on the box this year since we didn't have time to test alternatives. However, for next year, we plan to not use these converters at all and run the thrusters at a higher voltage. What we plan to do with this is that this will increase our efficiency for one. It'll also increase our total thrust. Right now, the buck converters play it very safe, and they limit the voltage to around 13.8 volts, which doesn't run the ESC at its complete capacity. So we plan to either change their battery size to accommodate for this, or maybe include a smaller buck converter in order to run the ESC at maybe somewhere around 20 volts in order to increase the total thrust and efficiency.
Going into this year's competition, we wanted our power management system to be as convenient as possible. From previous competitions, we saw great success in a very reliable power management system, as it allowed us to do more testing as the boat was in the water more often. The cleaner wiring, connector system, and battery hop swap features were implemented to make our electrical system as stable as possible and remove as much downtime in between test runs. This meant that we could get as much testing done as possible in those crucial few days leading up to competition. We hope to continue with this strategy next year and continue to improve the quality of design for the 2022 RoboBoat competition. Thank you.